Today I'm going to talk about Koin Annotations and Koin Compiler and how to do safe TI in Kotlin. My name is Gleb. I'm working here in Umain as a mobile developer, mostly KMP, but have to do everything, especially Android. That's my LinkedIn if anybody wants to connect. Okay. Louder. All right. The plan is I'm going to talk about KSP, how to do the shift to KSP, what are advanced features you can use with KSP. We're going to talk about KMP a bit, and yeah, that's it. That's the plan. First of all, the initial problem. Koin is a great framework. We'll all like it. We all like it, right? It's lightweight, pragmatic, heavily adopted in the KMP. So it's used by the most of large apps at the moment. But it's the biggest architectural flaw has always been reliance on runtime execution. In large-scale applications, finding dependency injection errors at time is a huge bottleneck for developer experience. So what's the solution for it? The modern way to do it is to shift left with KSP. KSP is Kotlin symbol processing, and instead of manually defining every single dependency in a central module file, we distribute the configuration. We simply annotate every class. And under the hood, this is powered by KSP. When you build your project, KSP scans your code base for the annotations that you put, and then it will automatically generate the standard Koin DSL module for you in compile time. One thing to expect, the first build after implementing KSP in your project will be slower. The processor needs to scan and generate code from scratch, but after that, the average build generation will be even shorter than you used to have. So how does it look in the code? On the left, you have the classic Koin DSL. We have to manually define a module, explicitly declare the single, and use get to resolve the dependency that we have inside. It works, but as your project grows, this module file became massive and perfect material for merge conflicts. But on the right side, we have the annotation with KSP way, and we just annotate our class of user repository, in this particular case, with single annotation or factory annotation. Both are supported. So how it works in 3 easy steps. So first of all, to define the core module, you just can do the module annotation. And you have also a component scan annotation, which you can put your package name in. So it only scans this particular package for the factory or single annotations. Then your KSP scans for all single and factory in the package and builds the tree for you. And you have app module dot module to get the whole tree. So obviously we don't trust something that is being done automatically and under the hood, so we want to verify it, and so we can get CI/CD feedback. If you if you push a commit, you can just get this instant CI/CD feedback that your tree is broken pretty much. So Koin actually provides one test function that will just verify that your tree works. You can just call app module.module.verify, and inside of it, you need to provide all the system dependencies. For example, for Android, it would be context, because Koin cannot generate it because it's not in your code and it's not annotated by default, so you'll have to provide it inside this function. Now that the graph is verified, the wiring is safe, we can look what you can actually do with it and do a little deep dive into Koin. So first, advanced function that is very interesting is scopes. So Koin annotation fully supports custom scopes. If you have an object that should only live during a specific period of time or user session, you can just define a scope. using the scope or scoped annotation. And in this case, the card will only live within this particular scope that you will annotate in your code. Another cool thing about Koin is collections. If you have an interface with multiple implementations, like for example in this particular case, form validators, email and phone validator, annotate them with single or factory, and they automatically bind to the interface. So to inject them all, you can use Koin function get all for this interface, and Koin will collect every registered binding that interface into a list. And in the future, if you want to add another one, you can just annotate with the same annotation. It will pick up it automatically. Injected parameters. Some values only exist at runtime: user ID, screen argument, session token, and annotation injected params lets you pass them at the moment of resolution, while Koin still wires everything else from the container. In this particular case, it's user ID, and you then inject it in runtime. I think not the last thing, but another thing: late declarations. Some stuff that you cannot provide right away to Koin on the build time. For example, like external SDKs, like here Firebase Analytics. So you can just signal Koin that you will provide it later with the provided annotation. String qualifiers. This is for like mocks or tests. That's very useful. So instead of using just named annotations like string annotations, you can just create your own qualifier and use it when you want to use the implementation of particular interface. So like to consume it, you will just use @prod. And one last but not least about the KMP. Koin annotations work across all KMP targets, including desktop, and out of the box. And you define the interface once in a common code. Each platform provides its own actual implementation, annotated with singular factory as usual. KSP runs separately for each target and generates platform-specific module. Android gets Android logger, iOS gets iOS logger, whatever. The rest of your shared code just injects platform logger without knowing or caring which platforms it's running on. So Koin is always pragmatic. KSP makes it safe. Annotation will move your DI configuration where it belongs, next to the code it describes. KSP decreases your boilerplate, and you just implementing something new, you'll just need to annotate new things and not like constantly searching where to add into the Koin file, where to get the value or something. So the advanced features, scopes, collections, injected parameters, late declarations, all follow the same principle: less boilerplate, more guarantees, and the code earlier. So, and one test verifies that your graph works. So you getting the information that your app will most likely crash on the launch before you actually deploy it or build it. So yeah, thank you for your attention. That was it.